video we are going to solve LeetCode problem number 1323, maximum 69 number. It is an easy problem. You are given a positive integer num consisting of only digits 6 and 9. Return the maximum number you can get by changing at most one digit. That is, either 6 can become 9 and 9 can become 6. So in this question, we have given an integer n. This number or this integer will only consist of digits 6 and 9. So out of this given number and a set of digits, we can change at most one digits. If it is possible for us to change, we can change at most one digit. We can either make the digit 6 to 9, or we can change the digit 9 to 6. After changing at most one digit, we need to return the maximum number that we can come off. Now we can, if we read the question properly, we have to return the maximum number. So as we have to return a maximum number, so in this scenario, we'll always change the digit 6 to 9. We are never going to change the digit 9 to 6 because we need to return the maximum value. And as 9 is greater than 6, then we'll always at most change one digit from 6 to 9. So let us take an example for better understanding this problem. Let num be 9669. So for this given number, in order for us to maximize this number by interchanging at least one digit from 6 to 9 or 9 to 6, we'll always choose digit 6 to change it to 9, because it is not possible for us to get the maximum possible digit by interchanging 9 with 6. So we always need to change the digit 6 with 9 in order for us to make it a maximum number. Now if we look into this example, or if we look into this number, there are two possible changes that we can make. We can either make this 6 as 9 or this 6 as 9. So in order to do this, we need to decide which digit to pick. So we can write this number as 9000 plus 600 plus 60 plus 9. If we add these four numbers, then we get this number. So we have just split it across these values. So now if we look into this pattern, if we go from right to left, we can see that each digit starting from the rightmost digit to left most digit is associated with the tens power. So we can see that 9 is multiplied by 10 raised to 0, 6 is multiplied by 10 raised to 1, 6 over here is multiplied by 10 raised to 2, and 9, the leftmost digit, is multiplied by 10 raised to 3. And this power of 10 increases from right to left by exactly 1. So in order for us to maximize the number, we need to change the digit 6 with the highest tens power. So because when we change the digit 6 with the highest tens power, only then we can maximize the difference, so we can make it a maximum number. This is a greedy problem where we need to maximize the possible number by interchanging the digits. So while finding this in a greedy manner, we need to pick the digit 6 with the maximum sixes. We need to pick or change the digit 6 to 9, which is having maximum tens power. So if we check over here, we are always going to replace this number over this number because it is having highest tens power associated to it. And in order for us to find the maximum digit 6 with highest, if we want to find the maximum change, then we need to replace a digit associated with maximum tens power to 9, and it is always going to be the leftmost 6 that is going to appear, because as we go from right to left the power increases by 1, and the leftmost digit or the last leftmost digit 6 will be the highest. So we'll start going from here and we'll go towards the left side and we'll check, okay, is this a digit 6? No. Is this a digit 6? Yes. So we'll give positions over here. And we'll keep a track of last position where a 6 has appeared. So we'll check, is this at 0th position, is the digit 6? No. At first position, is the position is the digit 6? Yes. So we'll keep track that at position 1 there is a 6. We'll go to position 2. Is it a 6? Yes. So we'll update it. So we'll keep it track of 2. Okay. Now we'll come over here. Is this a 6? No. So the last leftmost position at which 6 has appeared is 2. Also, we can see an interesting fact. The digit at 6, this digit 6 has associated with the power of 10 raised to 2. So the position at which the last 6 has appeared, it is having 10 to the power that position value as its associated value to it. So if, as we can see there, that at this position 6 has appearing at here at second position, it means that it is associated with 10 to the power 2. So in order for us to make this 6 digit 6 as 9, what we can do is we can add 3 over here, 3 at this digit to make it 9. So how we can do this? So we'll take the entire number 9 6 6 9, and we need to only add 3 over here. So we know that this digit is appearing at the second position. So we can do is we need to add 3 over here. So we'll take 3 into 10 to the power pos, because this digit is appearing at second position. So if we add 300, so it will be 3 into 100, and if we add it over here, then it means that it will be this 6 will turn into 9. So it finally be 9 9 6 9. This is the basic logic of our approach, and let us try to implement our logic. So initially we need to create a dummy variable where we need to store the value of num, because we need to have the original value of num as it is, and we are going to use this dummy variable y to iterate through all of these digits. So we will be moving from rightmost digit to the leftmost digit to the rightmost digit. So we need to keep on while iterating this, we need this dummy variable, and then we are going to need another variable named pos. So the pos will point to the position of last digit 6 that we have come across. So it will have the location or the position of the last 6 digit that we come across. So initially we'll set it as to -1, and we'll set a counter I which will initially be equal to 0. So we'll use this counter to move from left to right and to set the position values. The reason why we are setting pos is equal to -1, for example, in this question you can see that this is the maximum, it is maximum possible number, that is 9999, and there are no sixes over here, digit 6 over here. So if we find no 6 digits in the entire number, it means that we cannot maximize or make changes in that number. So we are going to return if we iterate through all of the digits and the positions value is -1, then we'll directly return it, because we cannot apply any change to maximize the number. So we'll apply a while loop. It's a simple while loop that we use to iterate to iterate all of the digits in that number. So val, we are always going to be iterating until val is greater than 0. So we'll calculate the remainder. It will be the rightmost digit. It will be val mod 10. So this will give us the remainder or the last digit. We'll check if remainder is equal to 6. Okay, if it is equal to 6, then pos the position's last value of 6 that we have come through will be of I. Okay, then we'll divide value by 10 so that we can move on to the next digit or the second digit that we have come across. Okay, and then we'll increment the counter. It will be val. Okay, now after going through all this, it will point towards the last digit. For example, it will come first over here. It will check, is it 9, is it 6? No. Is it 6? Yes. So pos will be set to 1 over here. Then it will again come over here, is it 6? Yes. So pos will be set to 2. It will again go 9, is it 6? No. So the last value of pos that we have come across will be 2, or the second position. So we now need to check that if we have found any digit 6 in the number. So if pos is not equal to -1, okay, so if it means that when the value of pos is not equal to -1, it means that we have found a digit 6 in that. So we'll take the original num variable and we will add 3, which because we need to change 6 into 9. So we'll add 3 into, we'll increment or we'll multiply it by 10's power. So 10 to the power pos, because pos is the location at which the digit is present, and it is also having the same power. As you can see here in this example, 6 is present if you go from left to right. If you go from right to left, starting from 0, 1, 2, 3. So 6 is present at 2. So it is associated power is 10 raised to 2. So we'll multiply 3 by 10 raised to power of pos, which is 2, which will be 300, and it will add it into it, and then it will become 9969, and will then return now. So let's check our code. Yeah, it is passing all the initial test cases. Now let us submit it. Yes, we can see it beats all the test cases. Now coming to the time and space complexity. Space complexity, comment this. We are not using any extra space over here, so it is going to be big O of 1, which is constant space. Now coming to this time complexity, we are just iterating digits of num. So we are going to iterate over all the digits of num, and it is basic that when we are iterating digits of a number, the time complexity associated to iterate the entire digits of a number is log n based to the power 10, but it will be log big O of log n in this case, which is logarithmic. just clean and simple solution without any extra space or any kind of other arrays or any difficult string operations. It's very easy, very efficient solution, and I hope that you guys like it. Thank you.